This is going to be a quick overview of clean architecture, which is a design pattern for microservices and REST APIs, or really it's how I'm applying it to microservices and REST APIs. And in particular, the pay-to-write database project has been refactored to reflect this architecture. And I thought it'd be a good idea to create a video to share with the other developers that I work with so that they can better easily understand why the code in that repository is arranged the way it is. There's a couple prerequisites that I recommend watching before you continue on with this video. You should pause this video and watch these two videos first. The first one, and actually before I go into this, all these links, I'm going to link to this gist on GitHub, and it'll have all the links in this video, and I'll also link to it in the show notes in YouTube. And anyways, you can comment there and leave comments, and all these links will be on there that you can follow. But there's this clean architecture video. Let me just show what it looks like. Oh shoot. But these are the two videos that you should check out before this one. Clean architecture for microservice APIs with Node.js and MongoDB and Express through Dev Mastery with Bill. I can't remember his name. It's escaping me for the moment. But anyways, this is a great introduction to the clean architecture concept and how it applies to a Node.js microservice. So you should really watch this video, understand this diagram that he walks through, and then look at the code that he uses in this example and really understand how he ties these entities, use cases, controllers, and external interfaces together in the way he does it. He does it differently than I do. He uses sort of older school syntax. He's using Jest as a testing framework, whereas I prefer to use Mocha. He's using Express, whereas I prefer to use Koa. So it's good to see the slight variation, but encompassment of the same ideas in the way that he does it versus the way that I do it in the code that I'm going to present today. And then in order to understand the code that I've written, this is something I recommend all developers who work for me watch or work with me watch, is this JavaScript testing patterns and best practices video that I put together. It's up on YouTube. And this just talks about the idea behind encapsulation and mocking and unit tests that I cover and is reflected in the code that I'm going to go through today. And I should point out, so I'm going to, like other videos I've made in the past, I'm going to cover a lot of the high level concepts first, and then I'll dive into the code at the end. So if you just want to get an understanding of what I'm talking at a high level, the first half of the video is for that, and then I'll dive into the code at the second half, and that's optional if you're a developer and you want to really dive into the code. So I've kind of been dancing around this, but the big question that should be in your mind is why clean architecture? Why some new thing? What about this is important and worth paying attention to? And there's really two things that clean architecture, or two problems that clean architecture solves. It manages increasing complexity as new features and interfaces are added over time. So if you have any experience building web apps, microservices, or really any application, you'll find that it grows. It increases in complexity over time. You add new features, it does more things, it does the old things better and in more sophisticated ways. So programs are always dealing with this growing complexity over time. And this architecture is a way to mitigate that, and this is largely what brought me to explore the clean architecture concept, is because this is something I've dealt with many times. I've built many production apps, and I've noticed this issue where they start off really good, but then over time just the increasing complexity makes it harder and harder and harder to maintain the code. And what I found through this clean architecture is that by identifying the architecture up front before there's a lot of code that's been written and sticking to it, that is the best. It's just like getting started with tests early. It has compounding effects. The earlier you do it, the better, the more value is realized throughout the life of the project. So if you're building a project and you expect it to live for any significant amount of time, it's not just some throwaway prototype. If you really expect it to, generate money and be worth maintaining over time, you should really think upfront about architecture. And even if you're a junior developer, you should be thinking about these things and trying to understand these things, because senior developers like me eventually pay a lot of attention to these things and find them valuable. Anyway, so that's the first thing: managing increasing complexity over time. There's a second, also very incredibly valuable feature, and that it provides defense against code rot by isolating the parts that rarely change from the parts that change frequently. So code rot is this idea that no software is created in isolation. All software depends on other software. So if you have a web app, well, that depends on a web browser. If you have a JavaScript app like a Node.js, well, that depends on some NPM packages. Everything depends on everything else in modern software, and so things are constantly changing out from under you, and that's code rot. That's like it's the idea that you can't just, software's never done. You can't just put it in a box and be like, okay, it's done, we never have to touch it again, because after a few months that software probably won't work because something else that it depends on has changed. And so this code rot is a constant cost. It's a constant risk. And the way this architecture is designed is it puts the stuff that changes the least often in the center, and the things like the frameworks and the database and the protocols like REST API versus gRPC versus RPC, all that stuff goes at the edges, so that they can easily be changed, updated, and changed out without affecting the parts in the middle that really don't need to change or be impacted by those kinds of changes, like the business logic. So those are really the two big reasons why. So if you give yourself an earnest attempt to try and understand this stuff, you get frustrated and you keep asking yourself, like, why am I learning this? This is the reason why. This is the slide you should keep coming back to. This is the value you get from really internalizing this architecture. So let me share this architectural diagram. That's the gist. Here is so these notes are in the Permissionless Software Foundation GitHub group, the Pay-to-Write database project or repository, under this dev docs directory, and there's a bunch of documents under that directory for developer documentation, and there's one titled Clean Architecture. So I'm basically going to be going off of this document, but this is the image of the clean architecture created by Uncle Bob, and what it represents is these four major categories: entities, use cases, adapters, and controllers. And actually, adapters and controllers are this green circle, with the blue circle being the actual, like, MongoDB, the web, the Koa framework, the actual frameworks and external interfaces and devices that you'd use. But the idea is that entities are the core concept of why the software is being written, and they won't change very often because everything about the software has to change. Like, literally everything. The whole reason for the software to exist has now changed if you change these entities. And then the use cases are the things that those entities do, or the things that other entities would do to other entities. Their actions, their verbs. And then this green circle are adapters. They're just like in mechanics, you talk about adapters where, say, you would adapt a transmission to a motor. You'd find some, like, chunk of metal that's capable of attaching those two pieces. That's the same idea with these controllers and adapters in the green circle, is that it's code that's part of your application so that these use cases and entities don't need to know anything specifically about MongoDB or REST APIs. They just talk to the adapter, and then the adapter is the only place where you have to have code that knows about some specific external interface, like a database or an API. And what it does is it protects the inner code from the outer code. And so it's literally an adapter, just like in mechanics, where you'd have some chunk of metal that can take the output of a motor and then apply that mechanical energy to a transmission, and it adapts those, it transfers that energy from one device to another. So if you've watched those prerequisite videos, you should be pretty familiar with this, and you should understand how it was applied in that other project. This diagram that I'm going to cover now, this is the file layout of the pay-to-write database project, and what you should be drawn to is the controllers, adapters, use cases, and entities box. So these reflect these outer circles, and then these arrows are dependencies. So the file being pointed to is a dependency of the file being pointed from. So the Koa framework depends on this controller. The controller depends on the use case. The use case depends on the entities. And this all follows these little arrows in the clean architecture diagram. And so let me go over some of these major features of the diagram. I just talked about that the blunt point of the arrow connects to file that depends on the pointy end of the arrow. So this is a Koa web app. So Koa is the spiritual successor of Express.js. They are both Node.js frameworks for building web servers and microservices. They were both written by the same developer. And because we are building within the context of Koa, it sort of screws up this idea of clean architecture. At least it can be a little difficult to wrap your head around, because you're basically starting here and you're working in, but the architecture is entity specific. So you think about it from here coming out. So basically, one of the things that I had to grapple with when I was trying to understand this is, like, where do I start and how does that reflect on the architecture? So this is where the program actually starts. It's in the bin folder in the server.js file. That's the first file that is run when the server starts, and it loads the controller, and that's how you bootstrap this whole architecture. But basically this file will load the controllers will load the adapters, and then it will also load the use cases, and then the use cases load the entities. And the entities here in this case for the pay-to-write database is an entry, a database entry. That's the only entity that exists in this so far. There will be another one called webhooks, and there will probably be others, but right now the main entity is just a database entry in the pay-to-write database. And then there's use cases for that entity. Add an entry to the database and read an entry to the database. Another use case would be delete an entry. And but anyways, these are the two use cases that I have coded up. And then there's several controllers. So the difference between a controller and an adapter, this is not reflected in the clean architecture concept. This is just an idea that I am using because it seems to fit well. But controllers are basically inputs, and adapters are basically outputs. Controllers are something that causes the system to react. And then an adapter is some output that the system needs to, something that it needs to change, like whether it's send a signal over IPFS, do something with the IPFS chord library, manipulate some data in the Orbit database or the local database. So these are the outputs. These are the things that the program is changing as a result of its inputs, which are the controllers. And so it has several controllers. It has the REST API controller, which is what the Koa framework deals with. it has the JSON RPC over IPFS, which is what the IPFS chord library is concerned with primarily. And then there's event-driven controllers, which is just different events happening in the system, like a peer database adds some data and it gets sent to the other peers in the network. That's going to cause an event. And so these dependencies, this controller library depends on all these different controllers, but then it sort of basically packages that up and passes them when it instantiates the use case. And I'll show that in the code at the end of this video. But what I want to capture here is just this high level overview of the place to start, the place to focus at the beginning is entities, use cases, controllers, and adapters. These are all in their own folders, and they all have an index.js file. And they will load the other libraries that are basically under their umbrella. And the other thing to get from here is the flow of dependencies, where you start and how things get loaded. If you understand these high-level concepts, reading the code is going to be a lot easier. Loads use cases. Each stage depends on the stage above it. Dependency injection is a really important concept, and that was covered in the other clean architecture video, but let me just real quick show the difference. Here is the index file for the use cases, and this is an example of a direct dependency. These are the other use cases, the add entry and read entry use cases using require, or you might use import. But this is a direct dependency. This is an example of dependency injection. Well, at least this one is, where I'm passing in a configuration object when I instantiate this class, and this is expecting an adapters property in that object, which contains the adapters, and so this use cases. If I go back to the diagram, this use cases file is directly depending on the specific use case libraries, and it is indirectly depending on the adapters through dependency injection. When the controller instantiates this use case library, it passes a handle to the adapters to it through this dependency injection. So this is how you achieve this arrow process in JavaScript, because this whole concept was not developed for JavaScript, and it's a little clunky when you try to apply it, and this was one of the biggest stumbling blocks I had to wrap my head around. This is how you follow this dependency. This is how you follow these dependency arrows, where these arrows represent direct dependencies and these arrows represent direct dependencies. But if something up here needs to depend on something below it, you do that through dependency injection, or as Uncle Bob calls it, dependency inversion. So this is a really important concept. You'll see this pattern over and over. So I'm passing in adapters. When you instantiate this, if you don't, it'll catch that and throw an error saying, no, you have to pass these adapters into the use cases. And that way, this depends on adapters at runtime, and this depends on these use cases at load time. So two different concerns. It's okay to have dependencies. You just have to understand like the flow of dependencies. It's a very important sort of thinking constraint in this architecture. And then encapsulation is a pattern that's also used to make testing easier. Here's a good example of both dependency injection and encapsulation. So I'm in the adapters under IPFS and the adapter for the IPFS chord library. So on the diagram, I'm at this file right here. And so this file directly depends on these external libraries, the BCHJS library and the IPFS chord library. We're making an adapter here for the IPFS chord library. So this requires an instance of IPFS, the Interplanetary File System. So it gets injected using dependency injection, and then it encapsulates its dependencies. So it using the this dot, and then so this IPFS chord library, which is instantiated up here, becomes part of the instance of the class. Same with the BCHJS library, becomes it gets instantiated. This is actually the class itself, and then this is an instance of the class. But what this lets me do when I'm writing tests is I can easily manipulate these variables and stub these out so that I'm testing what's in this file and not some external dependency of the file. And so this is an example of encapsulation where all these dependencies, whether they're injected or they're direct dependencies, they get encapsulated with the this keyword as a property of the this keyword in the constructor, which is an instance of this class, so that this instance of the class has all of its dependencies inside of it, and it's self-contained. And when I'm doing testing, unit tests, I can stub out these internal properties of the instance of the class and make them have whatever value I want, so that I can just focus on testing the code in this file, and I don't have to worry about side effects or other part or the dependencies that are outside of this file. So this encapsulation is an important concept, and I cover it in the testing pattern video, even though I don't really call it encapsulation in that video, but that's actually what it's called. Yeah, so that's pretty much, that concludes the high level part. If you really sort of understand how this is connected, I'm going to go through the code now and just walk through how this is all connected. And I'm just going to, rather than using my text editor, I'm going to use GitHub, because that's what everybody has access to, and it's the same for everyone. So here we are in the root repository. Hopefully you've read this README to understand like what the project is and what it does, the problems it solves. So there's this dev docs directory. I really recommend everyone read the documents in that directory. In the source folder, and before I go too far into the code, I'm going to do this code walkthrough, and then the last slide here is continue the conversation. I created a gist, and so if you have a GitHub account, or I think even if you don't have a GitHub account, you can leave comments here, you can ask questions. I'll also add links to all this stuff, and this link to this gist will be in the YouTube show notes. Okay, so to go through the code walkthrough, I'm in the source folder for the code, and you'll see that there are entities, use cases, controllers, and adapters. And inside each of these is an index.js file. So that corresponds directly with this index.js in each of these boxes. That's what these are. So these index.js files, they basically load all of the other stuff that's in these subdirectories, so that you can just deal with like entities as a whole or controllers as a whole. Now let me briefly talk about some of these others. Lib is just a general libraries folder, and it contains a lot of older code that will be removed. The middleware models and modules folder, these are left over from the Koa boilerplate that this project got started from. These will probably stay where they are because they have important parts of that framework, like user management and admin control and rate limits for the REST API. These should be brought into the controllers directory if I was being really pedantic, but I'll probably just leave them as they are because they're really part of that boilerplate. And same with RPC. This folder will probably go away. I've already copied them. This is for the JSON RPC. I've already moved all those folders into the controllers folder, so this will probably go away. So the reason I'm pointing these out is I don't want you to get confused. It's important to understand like the old code or the code inherited from previous projects versus the new code, and it's the new code that you should focus on. The old code can safely be ignored. So the main focus, if you want to wrap your head around this clean architecture, how it applies here, and how it's probably going to be applied to other projects I work on moving forward, is to understand these four folders: the entities, the use cases, the controllers, and the adapters. Um, okay, and so to dive a little deeper, the controllers, it has REST controllers, which is the same. It's the REST API, and so if you've ever built a REST API, you'll understand how that works. And and then the JSON RPC is triggered through over IPFS, the JSON RPC. And then the event-driven controller, there's just one, and that's when in this project there is when a peer database, because this is a peer-to-peer database, and so when another node or peer on the network updates their database with a piece of data, that data is going to ripple out through all the other peers that it's connected to, and that'll cause an event. And so that event trigger is a controller. And so all those things are in the controllers folder, and I've got one for JSON RPC, I've got one for REST. And then if we look in the index file, there's actually this one main attach controllers folder or function, and that's what, if you go scroll down to the bottom, that's what we export. So that's what gets used. And actually, let me take a step back and show the entry point. So this file is, the entry point is this server.js file in the bin folder. And it starts the server, it goes along, connects to Mongo, it loads the boilerplate controllers, and then here's where it calls our controllers index.js file, and then attaches the controllers to the app. And that's this file here that it calls, this controllers index.js file. There's one main function called attach controllers, and then it has these sub functions where it attaches the REST controllers, it starts IPFS and all the stuff that's connected to IPFS, like OrbitDB and the IPFS cord library. It attaches this event, the validation controller, which is an event that is triggered when a new entry to the database has been validated. And then finally it attaches the JSON RPC controllers. So that's the controllers library. Actually, we should go back in there, because that library, before it returns that function, it loads all these dependencies. It loads the adapters first, and let me go into that adapters folder. So it loads the adapters. Here's all the adapters. We've got IPFS, OrbitDB, sort of an adapter for the pay-to-write database, just an abstraction file, and then there's going to be webhooks, that's not implemented, and then the local database, which is MongoDB, but by abstracting it, we could swap that out with any type of database. So it loads this index.js file, which is it's not a class, it just loads these adapter files. So if you, going back to the diagram, there's the pay-to-write adapter and the local database adapter. It just loads these two, and then this in turn loads these other adapters. But going back to the controller file, it just basically loads the adapters, and then following the clean architecture, use cases cannot directly depend on the adapters, so we pass those up through dependency injection. So whereas the adapters is just a normal library file, use cases is a class, and so when we instantiate the class, we pass in the adapters. And yeah, so if we go back to the source folder and we go into the use cases, there's add entry and read entry. Those are the two use cases. And again, you can see dependency injection here. So it's expecting the adapters to get passed in when you instantiate the use cases, and it'll throw an error if you don't. And and then it just basically attaches those two use cases and passes it back. So going back to the controllers file, now we've got the adapters loaded and we've got the use cases loaded. And then in this particular instance, or in this particular thing, the use cases don't actually load the entities, although if this was more sophisticated, it could. These add entries directly import the entry, or like add entry directly imports this entry entity. And that's how it works out right now. But if part of this diagram is to sort of reflect the underlying symmetry and the underlying architecture of the architecture. So, anyways, this is ideally how it would all work, and hopefully, by walking through that code, you've got a sense of how direct dependencies and dependency injection are used to follow the clean architecture methodology. So I'm going to leave it here, and I don't want to go into too many more like specifics about this project, because what I've tried to cover is just the parts of this that is generally applicable to any project that would try to apply clean architecture to it. But the code is here to study. Hopefully between this repository and the other repository from the other clean architecture video, there's good examples for people who want to internalize this clean architecture concept and how to apply it in a JavaScript environment, particularly with a REST API and microservices. Again, going back to why are you doing this? Why is this important? It's these two reasons. These are the two very valuable benefits that you get by applying this architecture, and it is easier to apply it early than it is late. Just like with tests, it's very difficult to go back after you've gotten an app to production to then go back and try and pay down technical debt by writing tests. That's the hard way to do it. The easy way to do it is to write tests in the very beginning. Same thing here. As any developer gains experiences and tries to transition from a junior developer to a senior developer, it's more about thinking about the upfront things that you can do to save cost over time. And clean architecture and test-driven development are two of those things that really separates a senior developer from a junior developer. And so those are two things that you should be considering.